Good afternoon, everyone. Really excited to all of you here. This is my first speaking session in a long time, so please bear with me. But today I want to talk about observability with React and Node.js. Quickly, a little bit about me. I'm a staff software engineer with Twilio. I lead the full stack development on the phone numbers product. So if you have used Uber, DoorDash, then you've probably worked or interacted with some of the code that I have written. I'm really passionate about observability, performance, reliability, and sitting in a lot of incidents. I very strongly feel that it's not the systems which are bad, but it's mostly the processes which are bad. Or they have not evolved to a place where they should be supporting our on-call engineers. And that is where my passion for observability and performance comes in. Going through the agenda, I'll be talking about what I think the ideal solution is, what is our need for a unified view, how do we define our full stack observability, what do I say for correlating front-end and back-end data, case studies, and then I'll end the conversation with tools and best practices. Let's quickly look at a very high level what great observability looks like. So I always want to know what is broken, which is coming from logs, where it is broken, this will be my traces, and how it is affecting my system. But what do we have? We have too many moving parts across different layers. By layers, we have front end, we have back end, we have infrastructure, we might have data layers, we might have third-party API libraries as well. We have a highly distributed systems, and the systems keep changing constantly. These are very ephemeral systems. Sometimes you have some machines which have been brought up, then there is some error, so the load balancers take them out. So then once the load balancer take them out, essentially you end up losing out on the logs as well. Then correlation is also a very hard engineering problem. Until an engineer is sitting and trying to figure out what is happening on the back end, what is happening on the front end, it's very hard for the system to tell us what correlation exists in the existing knowledge we have. So for the scope of this call, and something that I have been doing lately at Twilio is that I realized because there are too many different systems, and essentially for observability, I was talking to Ronak earlier during the lunch, that it can start as soon as from your Wi-Fi network all the way to how a user interacts, right? We cannot do all of that. So let's just focus on what we can control, and keeping the scope minimal, why don't we just focus on the front end and back end in the beginning, and then we can abstract it to the other layers later on. Talking about modern web applications are increasingly complex. Traditional monitoring and traditional teams, how they are set up also, they take monitoring as two different efforts, and hence observability also becomes two different efforts. Front-end team is saying, everything looks great in front-end. Back-end team says, everything looks good in back-end, right? Leading to a lot of blind spots, bring them all in a room, and then you understand what exactly is going on. Then the reason behind unified full-stack observability is also to give a holistic understanding of this application behavior across all layers. So what I propose is that you mix front-end monitoring and back-end monitoring into a simple dashboard or a cohesive unit, and then we call it full-stack observability. So let's quickly define for React and Node.js, assuming you have a one stack, what would full-stack observability mean? It would mean you're monitoring the entire application stack from React in the front end and Node.js. Then you emphasize on what are the critical connections between dependencies between front end and back end. And hopefully you have it in your dashboard or any other metrics. What the advantage with this is that you also have a single platform or tightly integrated tools for data correction. For example, if you're using Datadog dashboard, then you have front-end system also for front-end monitoring of the same dashboard. And then you have back-end monitoring also as part of the same dashboard. And then again, as I mentioned in the previous slide, this is very different from siloed monitoring where you have back-end teams talking about my systems are working fine. It must be on the front end. And then front-end teams are telling that my systems are also fine. But the SRE team is trying to figure out if both are fine, then where is our problem? Quickly, what are the benefits of such an approach? A holistic view will enable you to have a quicker RCA, reducing your minimum time to resolve. I remember an incident where at 3 a.m., messaging team paged me at Twilio, and they were like, I think there is some issue with one of the Node.js services that phone numbers own. And then I look at my Node.js dashboard and I'm like, everything looks good. There's nothing wrong with my system. So then I page my backend team, the core infrastructure team, and they're like, but I think everything looks good on me as well, on my end as well. Let's page the edge connectivity team. And 30 minutes go by, and then suddenly you have 5 people on a call, and everybody thinks that their system is fine, but the customer is still having trouble. That brings me to the second point, improve team collaboration. I want to set up a system where you have shared understanding instead of breaking people down into silos and paging, and then also focusing on identifying bottlenecks across both front end and back end for enhanced performance insights. I'll go through some case studies where this will be more clear, but what I mean here is that, let's say if you have an action on the front end, which is repeatedly calling the same backend API call in a short span of time, why is it not cached? Why is it not being referenced directly from CDN? If you do that, you cause less load on the backend, and you're also making an efficient use of your systems. The next is data-driven decision making. I want to focus on this related to optimization and resource allocation. What here is that, let's say if we have Black Friday is one of Twilio's major events during like election time or during Black Friday when you have a lot of people making a lot of orders, right? We already know that this is going to happen. So how do we make our system smart enough that, one, the resources, they might be manually scaled or they might be scaled, let's say 1 or 2 weeks ago by the SRE team itself, but we are also able to understand why those particular spikes are happening and what can we learn from them so that in future we can handle them better. The last one being proactive issue detection. By this, that a DDoS kind of an attack happening on our front-end layer, then it should be properly traced back to backend and infrastructure layer as well. So they know that these are all correlated in one. So quickly looking at achieving end-to-end visibility, I briefly touched base upon traces. So by trace propagation, the unique IDs which are generated on the front end, WTC trace context and passed along to the backend. Then you have correlation IDs. They can, if you cannot do trace IDs, then you can focus on correlation ID. You basically generate them on the front end and they go all the way up to your backend. So if you're looking at the logs in the backend, you will be able to correlate it to the respective front end. Session IDs being every time a user is logging in, you can relate it to a given session ID and it can be traced all the way back. Then you basically can use these trace and correlation IDs all together. Then you have user monitoring and application APM integration, which are both offered by Datadog out of the box right now. And open telemetry, I added an example here. So as you can see, there is a trace parent ID and a trace state ID. So the trace parent ID would go all the way from start to the finish, which can be used to go through the logs and correlate it to what action initiated it in the front end, all the way to which DB was referenced, if any, or where did the backend query ended up going. Quickly, let's also talk about some of the key performance indicators, which I think are very critical for if you're looking at a full stack observability at a high level. So we have user perceived latency. This is basically what is the user experiencing on, this will be a mixture of what user sees on the front end and the back end. Then you have error rates. So errors could either be on the front end JavaScript errors, or you could have some back end errors. This could be related to database, or it could be related to any of the APIs. Then you have request latency, which is basically the time in browser. So it's like a holistic view of your whole request lifecycle and trying to figure out how much time did it really take. You have throughput, where you basically capture the API request processed and how much is our application's capacity. Are we able to scale based on the load? Then resource utilization, which is again a mixture of how browser is able to handle, what is the local cache we are able to support, if there are any memory leaks on the front end or on the back end. User engagement metrics. So Eve does a really good job at it. This includes what are the page views, what is the exact URL that the user is calling, and conversion rates. If you have an e-commerce app, or conversion rates, if the conversion rates are dropping, then you can take a look at why the conversion rates are dropping. And last but not the least, core web vitals. So this is basically like protocols like LCP, FID, or you basically try to figure out what are the backend impacts on content delivery. Let's quickly, again, I talked about a lot of things. I want to, for this talk, focus on distributed tracing, which is something we have recently started at Twilio, and we're trying to do it across all of our stack right now. Again, as I mentioned before, distributed tracing meaning you basically follow the path of request as it traverses through the whole architecture. And this helps us find out all the performance bottlenecks. Whether it's a latency issue, it could be on the BFF layer, which is backend for front-end layer, or it's going all the way to the backend. There is again, in a complex scenario, there could be one service acting up, causing the whole system to slow down. So figuring that piece out, and then understanding service dependencies and improve observability. So by this, I mean that you not only look at each service in a different silo, but as a cohesive unit. If you see that something is slowing down, that what can you do going forward, or in the event of high traffic events like Black Friday or election time, what we can do to understand and improve our overall understanding of system behavior so we can prepare better. Quickly touching base on how we implement it. So we have traces, which is the entire life cycle of the request. You have spans. So what I mean by span here is that when the user starts its request, front end becomes a span. The front end is talking to a BFF, that is another span. Then when it goes from BFF to any of the API gateways, that is another span. And then from API gateway, it could go to a core backend service in Java, another span followed by like DPR. So each one of these is a different span, an individual unit, and they all are connected using traces. And that is what context propagation actually is, that the trace parent ID passing through the whole link. So you can trace it down in each system and figure out what's going on. OpenTelemetry does a very good job at this, integrating traces, logs, and metrics. And then you can use something like Jaeger or Zipkin to visualize it. And so wanted to quickly touch base on few of those scenarios which I felt I've gone through in my experience, where these things could have been really useful. One is analyzing user navigation patterns leading to high backend resource. So I remember this example where I was part of a startup earlier, and we found out that we did not do a very good job at caching some of the product details on the product details page. So essentially, when a user moved from product A to product B, all the assets, not just the product specific assets, but all the marketplace assets were reloading. Essentially, we were making a lot more backend API calls than they were really needed. So the user navigation pattern could have been much more smarter, and we could have used cache and CDN to avoid making excessive backend resource calls, which was causing extra requests for the backend. Then another issue one time I saw was that there was a payment error happening on the front end, and it wasn't because the external payment library was going down. So in that case, what my API gateway should have been able to handle is that shield those 500 by saying that this backend service is not responding right now. And so my front end, if received that call, should have been smart enough to say that this library is down right now. You only have these many options to pay from, or like any more user-friendly errors. Another thing I saw once was that there was a slow front end page and intermittent failures on the front end actions, and they were being caused because one of the gateway was timing out. The gateway was timing out because the backend was taking a really long time. So if you had a trace ID here, then you would basically be able to figure out that the same API call on the backend is failing and trace it all the way to the front end, saying that the gateway is timing out. One last example was, I remember this a couple of years ago, where the add to cart started suddenly failing. It was one of the Black Friday events. And the reason for this failing was because suddenly one of our services in the backend was not scaled enough for a Black Friday event. And it was one of those services which was a compliance issue. So because we do not let the user add to cart unless we have made sure that the user can purchase that product, we didn't think that the Black Friday event could cause so many compliance requests all of a sudden as well. So the compliance service, even though it was a small piece of the puzzle, but it was not scaled up perfectly, it ended up causing a lot of issues on the front end as well. So fortunately, we do have a lot of observability platforms right now, starting from Data, which, as I mentioned, performs real user monitoring with APM. You have New Relic, very exclusive solutions for Stack, Honeycomb giving us a very unified visualization for telemetry, Dynatrace, Elastic Observability. Again, Dynatrace is AI focused. Elastic Observability focuses mostly on Elastic Stack. You have Grafana, Observe. And then if you want to go with any open source platform, let's go with OpenObserve. OpenTelemetry, I think, is by far like much better than anything else in my experience. And it's something we are POCing at Twilio as well as a possible solution for all of our observability concerns. I want to say one more thing here. There is no one size fits all in this. each team has their own requirements, each team has their own business cases, but as long as, so one other thing that I learned from Datadog is that it's very sticky and it's very expensive. So you build all these migration plans, you build all these, and then suddenly you realize that you're paying a lot of money to Datadog. Right? So scale as much as needed. Referring to one of the talks earlier, it's not like microservice is the best solution. If you're starting small, you can start from a monolith and then you can scale up to microservices. Similarly for observability, see what fits your shoe and then go ahead with that. Some of the best practices I want to discuss based on what we've discussed so far. So one of the things that I've made an engineering discipline at Twilio in my team is that we have unified dashboard visualizing key metrics and traces from both front end and back end, and they all need to be in one view altogether. They cannot be in multiple views or be distributed across multiple teams. Secondly, setting up alerts based on correlated front end and back end data. So this means that, let's say if users in Australia are not able to purchase some phone numbers, and if that is a page that is coming from synthetic test in front end, then we need to relate it to, are the backend API calls for buying a phone number successful in Datadog in backend? If they are not successful in backend, then this means that this front end could directly be related to that backend issue. So we want our systems to be smart enough to be able to correlate these data. Then anomaly detection to proactively identify any unusual behavior. I remember we had a customer recently onboarded, so they were completely new to Twilio ecosystem, and they made almost 1 million calls in a period of 7 days because they were trying to procure a set of phone numbers. So what they did was they wrote a script which they thought they would purchase phone numbers from Twilio. But what ended up happening was that they kept hitting the wrong public API endpoint. And because of that, they kept repeating it until they are able to successfully purchase the phone number. But what that did was that our systems could not scale that quickly to the point that they were creating so many requests. So our engineers started getting paged saying that this is an anomaly or why this customer suddenly raising so many requests. Then another thing is effective tagging strategies. We are testing out some AI in this space right now. What I mean by this is that, let's say one of our core services is getting a lot of elevated 500, and it's possibly because of a given endpoint. Then we want to be able to tag it to that endpoint so that when we do the analysis, we do our on-call analysis on a weekly basis. We can figure out which endpoint is causing these issues, and then we can proactively take measurements to why is this endpoint getting so much traffic? Is it a bad query, or is it determined to handle so much load? If it is mandatory to handle so much load, then let's scale the resource as much so that it can handle it. Again, establishing clear observability goals in SLOs. The goals and observability goals should not be just about business and revenue. They should also be able to relate to our engineering discipline and building practices in a way that we can scale systems whenever needed. Then quickly talking about involving both front-end and back-end teams in defining these alerts and dashboards. So if our app is full stack, then our dashboard should also be full stack. They should not be front-end and back-end. Quickly to summarize some of the learnings we have: unified full stack observability to eliminate our blind spots, correlating front-end and back-end data, full stack APIs driving back-end decisions, optimizing the performance and delivering amazing UX experiences. Again, we have some amazing modern tools empowering teams and breaking the front-end and back-end silos. And then I really look forward to how we can utilize AI and ML to use predictive insights auto-generated instead of code solely relying on engineering capacity to figure out root causes and be able to handle it. Yeah, that's it. And thank you for your time today. Connect with me on LinkedIn.